All right, everyone, welcome back. Another great week here in Virginia. It's raining and cold outside. Looks like winter's still here. All right, but another great week of classes. Enjoyed meeting all of you. Hopefully, you guys are logging in, finding more information on this YouTube channel, and we're getting some of these questions answered. Now, one of the questions we had in class this week is one that I typically see, I've been seeing since the 2021 change of the exam. There's been less emphasis on test questions that make you calculate things. So students will get to the earned value portion of the class and they'll see a very abbreviated class on earned value and oftentimes feel like they didn't quite get it, they don't quite understand it. And it's because we're not emphasizing it like we used to. In previous versions of this exam, we would spend a lot more time talking about the math. Everyone would, right? Every single study guide out there would spend a lot of time talking about the mathematics because students had to memorize the formulas and then use them on test questions to get questions right, and to actually calculate stuff. Well, the current exam versions, don't make you do as much calculation, although you'll need to understand the formulas to answer questions at times. So you still need to understand the functions of the formulas and why they're being used, but not necessarily the actual putting the numbers in a calculator to get an answer. So because of that, the slide deck has been changed in every course, right? They don't talk as much about earned value as we used to. It's not like you can just show someone a bit of the topic and then just be like, good enough. Like the normal student is going to have questions, right? Especially you get some of those really inquisitive minds in class, and they're like, wait, why? Because they want to know they want to know more behind it. All right, so understand that earned value has been around in project management since the 50s. It's been in government projects for quite a long time. It's still used. It is rare in projects, just like all the tools and techniques. They're rare in different industries, but they're used more than the other. Anyway, so earned value management is tight at the hip with a lot of what we're talking about in PERT, right? When we talked about PERT and estimating in our class, the program evaluation review technique developed by the United States Navy. All right. So it's those same programs came out a way of controlling programs and projects mathematically. And that's where earned value comes from. All right, so we don't really give you the background in class anymore, in like in the doing of the workbooks and stuff like that. So really, we're just preparing you to answer the questions you're going to see on your test, which are pretty straightforward. When it's asking you about schedule variance and cost variance and being able to say how the project's doing. That's for the most part is the test question, but it doesn't mean students aren't going to spend a lot of time studying. And as an instructor, my job is to shorten that learning curve, right? To take less time studying. So if you want more information on earned value, right? You want to really know, right? You want to do the math, you want to fully understand it. Maybe your class wasn't on it. Here is an older version, right? So I'm going to follow this with a video from a course that I did back when we were teaching earned value. It's the nitty-gritty version of it. So we'll get the full explanation of it and like in how to do each one of the formulas and how to apply them to a test question. Although nowadays are no longer asked to do the math, you're asked to understand it. So in this version of the video, students had to calculate their estimate at completion. They had to calculate TCPI. They had to calculate estimate to completion on test questions. But on your test question, you're not calculating. You're told your estimate to completion is $200,000. And you're asked, what does that mean? And if you don't know where the numbers come from, if you don't know what the formulas are, then you're going to have a really hard time answering the question. So hopefully by seeing the elbow work, yeah, in the doing of the math, you'll better understand its application. So that's the purpose of this video. So I know it is a retro video, and I know it's covering topics on the exam that aren't tested like they currently are. But hopefully it's answering those questions for you as a student on where the math is coming from. All right, so we're going to walk you through earned value for the exam in this section, but there's other ways in which we could do this, determine how we're doing budget-wise. So that's the goal of the process, to say over budget or under budget, right? So simplistically, we could just look at some of the project data, right? And we see that as one of the inputs, project data, explaining that this piece of work cost $1 billion. It was supposed to cost $1 million. I'm over budget, right? So you don't need a lot of complicated math there. It's pretty common sense. So oftentimes it's pretty straightforward, but there are other ways in which we could do this. It's more complicated using earned value. All right, so earned value. When we're actually doing this in projects, it's built up throughout the project methodology so that we can use earned value during the project. And this goes back to the idea of the work breakdown structure. So remember, the work breakdown structure has all these different boxes on it. Each box with an account code we called a control account. That box represents a piece of work and an estimate in dollars to do that piece of work. And we can control it because we've estimated for it. So wherever we see a control account, we could use earned value for that piece of work to determine over budget, under budget, ahead of schedule, behind schedule. And so in the earned value projects, they're doing this concept for like all the different work packages, right? And then averaging it to figure out how the project is doing overall. Because some of the work packages you might be ahead of schedule on, others you might be behind schedule on, right? And to do this, it requires software, right? You don't have software on the exam to do it. So you're using earned value light. You're looking at one like really cheesy like example project that's very simplistic with like one element of work to say when the project should end, right? The testing scenario is pretty straightforward, and honestly, it's earned value light. All right, so we're going to go through earned value and all the different formulas that you could possibly see on this exam. But once again, you won't be calculating it. You'll have to understand it. Now, the other tool down there, tool number 3, the 2 completion performance index. All right, that's another way of, well, it's an adaptation to earned value. It's how we fix the project, right, and get us back on track over time. So it's saying, okay, we're behind schedule, we're over budget, and this is how much time we have remaining. We need to achieve this rate of work and spending throughout the rest of the timeline to catch up at the very, very end. So that's TCPI, the 2 completion performance index. It's the fixer. And we'll talk more about how that's calculated in just a moment. But typically, like we said, we're using our systems to do this. Tool number 4, your system, all right? But you don't have that on the exam. You have, essentially a dollar store calculator that's part of the software, and that's it. So it's going to be pretty straightforward. So here we go. Earned value. Yay. All right. So earned value analysis is discussed in process 7.4. I believe this is page 187 or something in the PMBOK guide that has all of the earned value terms on it with like their definitions and their acronyms. Well, we've kind of rearranged that to show you more like steps and like how to attack an earned value question. So if you're having to calculate an earned value question, if you were, which you no longer are, what you would do is read through the test question, determine the units of measure, like what is the unit of time? Is it measured in months, is it weeks, days, hours, what is that unit of time and what is it worth? Once we determine that, then it's about like, what is the unit of work? What are we making? And what is it worth? Once we've done that, then we can calculate what's called the 4 basic values. And the 4 basic values are right here, these first 4 terms, right? And we need those in order to do everything else, is determine these 4 basic values. Question, are we given any blank paper for this test? We used to be, not anymore though, thanks to the pandemic. All right, so now because they offer this test virtually to anyone who can take it from home, we have to have the same conditions. So there's no longer paper. Now it's a little whiteboard. It's part of the software. It's kind of annoying. All right, so it's like the early version of like Windows Draw or Microsoft Draw, whatever it was. So you can open up like PowerPoint, and it's similar to a PowerPoint slide, or you can type on it, put shapes on it, draw on it. All right. So oftentimes people are doing their earned value calculations on that whiteboard, right? So, all right, here we go. So we're attacking an earned value question. The first thing we need to do, all right, step 1, is determine what is the unit of time, right? You read through the test question, the blah, blah, blah will say it over and over and over and over again. Like months. All right, so once you figure out what is the unit of time, we have to then determine how much that unit of time is worth according to the plan. What is a month worth to us? After we've done that, we have to figure out what is the unit of work. What are we making? All right, it'll say it over and over again. Cars. Okay, we're making cars. So what is every car worth? That's the next question. Once we've determined that, and only after we've determined that, can we then figure out the 4 basic values. So if you struggle at earned value, most likely it's because you didn't do step 1 and step 2. Most likely it's because you didn't understand the concept of taking time, turning it into dollars. Work, turn it into dollars. Explain everything in dollars. That's the concept. If you don't do that, you're going to struggle with everything in earned value. All right. So let's give an example. I'm in the sound studio today. So imagine I'm pulling all the foam off the walls, and we're going to put drywall up and we're going to paint it. I'm not going to, but let's imagine that's what's going to happen, right? So there's 4 walls in my sound studio, right? So we have wall number 1, wall number 2, wall number 3, and wall number 4. Let's say they're all the same size. They're not, but let's say they were. And I'm going to get a contractor in here to paint these walls. So I bring a contractor in and they're like, oh yeah, these walls, I can paint these 4 walls. No problem. I paint off a daily rate though. All right. I paint, for $100 per day. And these 4 walls, it should take me 4 days to complete those 4 walls. Yes, I can do this. 4 walls, 4 days. All right. So now we have enough information to do earned value based off what the contractor just told us. And that's how it usually works. Earned value, we're setting up and planning, right? We're trying to say this is what's supposed to happen. All right. And then we're using those units to measure how things are actually happening during execution. So we see like some of these 4 basic values are determined in planning. And that's what the slide suggests, like budget at completion is determined in planning and the planned value is determined in planning. All right. So slowest painter ever. All right. So yeah, he's going to come in here. He's going to paint 1 wall per day. So we already determined what is the unit of time was a day, right? And he said every day was worth $100, right? And the unit of work was a wall, but he didn't say what every wall was worth, did he? He just said he's going to paint a wall in a day. So logically, what is every wall worth to us? Write it in the chat. And it's a bunch of simple questions here. Participation helps for attendance. Just saying. There we go. Yeah, so $100, right? So we're saying that logically, every wall is worth $100 to us. Okay, so if every wall is worth 100, this wall is worth $100 to us according to the plan. This wall is worth $100 to us according to the plan. This wall is worth $100 to us according to the plan. And that last wall is worth $100 to us according to the plan. Each wall is worth $100. All right, so if that's the case, the term budget at completion, BAC, means the budgeted value of all of the work according to this fool's estimates once I've completed it all, right? It's based off the estimate. So what is the value of all of the work? $400. Excellent, right? So the budget at completion, to determine it, all we have to do is take the unit of work, W, the walls, and multiply it by the number of units. Look, there's 4 of them. 4 times 100, $400. So the budget at completion for this cheesy example is $400. So we're saying this project should be over once we spend $400 if everything goes according to plan. So we budget $400 for it, put $400 aside, bam. All right. Now, planned value. Most students who struggle in this topic of earned value struggle the most with the concept of planned value. And the reason why they struggle is because of how it's defined. It's defined as planned value, singular, when in reality it's planned values, plural. There's a planned value for every unit of time. Okay, according to the plan, how many walls should be done at the end of day 1? Yeah, right. 1, right? Okay, according to my plan, how many walls should be done at the end of day 2 in total? 2, right? And then how many walls should be done at the end of day 3? 3, right? And according to the plan, how many walls should be done at the end of day 4? 4. Now, earned value, we discussed this in dollars, right? So at the end of day 1, what is the value of the work that should be done? We said we should have 1 wall. It should be $100, right? Because every wall is worth $100. So that means that the planned value, PV, for day 1, subscript 1, would equal $100. So at the end of day 1, we should have spent $100 and have 1 wall painted. Whereas at the end of day 2, the planned value for day 2, PV sub 2, would now be $200. That we have $200 worth of walls painted. That's the plan. All right, so planned value is about that moment in time. So for whatever the unit is, months, for example, you would have a planned value for every month. In this case, the unit of time is days. So we have a planned value for every day. All right, so we can draw this out if we wanted to. Now, you don't have to draw the diagrams on this exam, but you might have to interpret one. So here's a small cheesy one for you, right? The whole project should take $400, right? There's 400. That makes this 200. There's 100. There's 300. All right. And the whole project should take 4 days, right? Done on day 4. So that makes this day 2. Here's day 1. Here's day 3. All right. So at the end of day 1, we're saying we should have spent $100 and have one wall completed. That's what the plan suggests, right? So this dot would represent the planned value for day 1. Have one wall done, spend $100. The planned value for day 2 would be up here. Have 2 walls done and have spent $200. The planned value for day 3 is here. Planned value for day 4 here. All right. So each one of those dots represents a planned value. This one's PV sub 1. That one's PV sub 2. That one's PV sub 3. That one's PV sub 4. The subscript is important, right? So usually we're writing it out like PV subscript 1, representing the first moment of time, that first unit. All right, so PV sub 1 equals $100. We should have spent $100 according to the plan and have $100 worth of work done. That's what the plan says. So each one of these dots, if I draw a line through it, it would be straight, but I hand drew it, so it's not. But that line would represent the performance measurement baseline. That line represents what's supposed to happen according to the plan. Now, the reason why people confuse planned value and budget at completion is because this last planned value right here, that PV sub 4 equals $400, right? And that should equal the budget at completion, or you messed it up. So the very last planned value and the budget at completion should be the same number. And that's why people confuse this. They think they're the same thing, but they're not. There's one budget at completion, and there's a planned value for every unit of time. Yes, planned value is cumulative, right? It's about that moment in time. So on day 2, we've planned to have 2 walls done and have spent $200 to get it done. On day 3, we plan to have 3 walls done and have spent $300 to get it done. All right, so that's how we determine the planned value. Earned value is a little different. Earned value and actual cost, that comes from the doing of the work itself. So let's say we're knocking out work, right? Okay, it's end of day 1. I come down to the basement and I'm expecting to see 1 wall painted, right? That's what I'm expecting. But when I come downstairs, I'm surprised because not only has he painted wall number 1 over here, that's done. He painted it. He also painted wall number 2. What? We're a wall ahead. He was supposed to paint 1 wall. He painted 2 in 1 day. We're crushing it, right? We have 2 walls done at the end of day 1. We were supposed to have just 1, but we have 2 done. How are we doing schedule-wise? If we're supposed to have 1 wall done and we have 2 walls done, how are we doing on the schedule? Right in the chat. Yeah, we're ahead of schedule, right? We're ahead of schedule by how much? How much money? On 1 day, yes, but we said 1 day is worth $100. There we go. Now we're talking earned value. We're $100 ahead of schedule, right? Because we have 1 wall ahead. Every wall is worth $100. Or 1 day ahead. Every day is worth $100. All right, so that's why we're using the unit of measure as $1. Okay, so now that we've determined our earned value, right, that we have 2 walls that are done, right? The earned value is the value of the work that is complete, right? We said each wall is worth $100, right? So in that case, how much work is complete in dollars? If each wall is worth 100, right? We've completed $200 worth of work at the end of day 1. So our earned value would be represented by this blue dot here. $200 of work is completed at the end of day 1. And so when the earned value dot is above the planned value dot for that unit of time, that means we're ahead of schedule. We're supposed to be down here, but we're up here. We're ahead of schedule. All right, so when we start comparing earned value to planned value, we start understanding ahead of schedule, behind schedule. That's what's utilized in schedule variance and schedule performance index, comparing those 2 variables to one another, what was supposed to happen and what's actually happening. All right, so that's earned value. All right, so we're saying at the end of day 1, earned value subscript 1, EV1, we've completed $200 worth of work. All right, actual cost. Actual cost is the money that was actually spent here to get that work done. We're not paying the guy by the wall, are we? We're paying him by the day. So how many dollars were actually spent at the end of day one? Right, so $100, right, were spent at the end of day one. So if we plot that, it would plot right here on the planned value, right? Right, hit that mark. All right, so we spent $100 to complete $200 worth of work. That means for every dollar I'm putting down, I'm getting $2 worth of work out of it. How are we doing budget wise? Right? If we're every dollar we're spending is returning $2 worth of work. Right, we're going to be under budget. We're under budget right now because we're spending $1, we're getting $2 worth of work out of it. All right, so when we compare the earned value to the actual cost, these two, that's how we determine cost variance and cost performance index, over budget, under budget. All right, now, once we've determined the earned value and the actual cost, we're saying our actual cost at the end of day one. I'm not going to use yellow. No one can see yellow. Go back to you color red. Thank you. There. All right. So at the end of day one, our actual cost is $100, just like the plan was supposed to be. We spent $100, but we got more work done with it, right? So now what we're going to do is we could determine project health, but we're going to just kind of skip this conversation of project health. So project health is determined here with these concepts. We'll talk about those on the next slide. The next thing after you determine project health is we use that to calculate or forecast when the project should end, our estimate at completion, or EAC. All right, so we've completed 2 walls at the end of day one, right? There's a total of 4 walls. On what day does this project end? It ends at the end of what day? Hold on now. He said he was going to paint 1 wall per day, but he didn't. He painted 2 walls in a day. Apparently he can paint much faster than, yeah, right? So if he can paint much faster, he paints 2 walls in a day, and there's a total of 4 walls. This whole thing's taking 2 days. Logic dictates he's done at the end of day 2. Now, how much money would we have spent to complete all 4 walls if that's the case? Right, $200. So we're saying we spend $200 and this whole project's over, right? And so that's a way of forecasting the project, right? So we spent $100 so far, spend another $100, the project's over once we spend $200. So that's one way of determining the estimate at completion, EAC, by saying what happened yesterday should continue to happen, right? That's what logic dictates. But let's imagine we know more about the situation. Let's say we walk in and there he is, he's putting away his paintbrushes. And we're like, oh man, you crushed it. You're painting 2 walls in a day. You know, how'd you paint so fast? And he's like, well, actually, what happened was my brother's best friend's nephew stayed home from school and he helped me paint. And I'm like, well, that's nice of him. I'm not paying any more for that. But okay, well, what school does he go to? UC Boulder, Colorado State. And he's like, oh, no, he's in grade school. Like, grade school? That's child labor. You can't do that. He's like, that wrong? Yes, against the law. He's like, my bad. He's like, maybe tomorrow, no child labor. And he's like, okay. So now we know. Now we know why he got ahead. He cheated, right? And he's not going to do that ever again, right? So we have 2 walls done at the end of day 1 because he cheated. At the end of day 2, how many walls in total do you think will be done? Right, 3. He goes back to that original estimated rate of 1 wall per day, right? So on the second day, he finishes the 3rd wall, which means he ends the project on day 3, finishing the 4th wall, right? So if it's going to take us 3 days to end the project now, how many dollars will we have to spend in order to complete the project now that we know how he got ahead because he cheated? How many dollars will it cost at the end of this thing? Good, $300. Our estimate at completion is $300. We're saying because he cheated, right, on day 1, we're not going to see that rate of work from here on out. we're going back to that original estimated rate for the remainder of the work, 1 wall per day, it's going to cost a total of $300 and the project's over. It's a different estimate at completion. So typically we express estimate at completion as a dashed line from actual cost. There's different ways in which it could show up on a chart. The ones I like show it as a dashed line from actual cost, ending the project on day 3 at $300, bam, right? And so you'd have like that green dot representing the estimate at completion, EAC. All right. So if we know the project ends once we've spent $300, and right now we have spent $100, estimate to completion is used to say how many more dollars from right now. So we've spent $100, here we are at this yellow dot, and we're trying to figure out how many more dollars of spending are needed to get to this green dot. How many more dollars? So if we're saying the estimate at completion is 300, right? That was our EAC, let's say, for our example. Let me write that down on the slide so you guys can see it. So we're going to say that the estimate at completion is $300. And you're being asked how many more dollars we need to spend to end this nightmare. That's usually the way it's put too from your boss, is how many more dollars shall I end this nightmare, Mike? All right, so we say, boss, so far we've spent 100. The project's over when we spend 300. So another $200 of spending and the project's over. So estimate to completion always answers the question, how many more dollars? All right, variance at completion is how far are you off from what you originally said. So originally we said the project ends here, this last planned value. Now we're saying it ends here. So what's the difference between these two dots? Between the estimate at completion of $300 and what we originally said, $400. Right, we're $100 off. Boss, I'm saving you $100. That's our variance at completion. Variance, difference, subtraction, right? We said 400 originally. Now we're saying 300. I'm saving you $100. I know you've thought about this. It's just that we give it a fancy name and a calculation, you lose it. So look, here we are. In this case, we're ahead of schedule. So TCPI will tell you how to hit the budget at completion. So if we're going to hit the budget at completion in this example, we'd have to slow down. So if we use TCPI in this situation, it would be telling us to slow down, right? And then oftentimes project managers don't want to slow down, right? But sometimes that's what you have to do. All right. So if we're using TCPI here, and we want to end this project, we have to have some sort of reason as to why. You know, maybe I had to ask for the budget to redo the basement from my wife. And I know that if I don't use that budget, the next time I ask for budgets to do something, she gives me less than what I asked for, right? So I want to spend all of my budget. All right. So I'm not saying that's what actually happens. Maybe. All right. So anyway, I realized the contract was going to be completed having only spent $300. Like, ooh, that's not good. I want to make sure he uses up all of the budget. And so, hey, bro, can I talk to you for a second? He's like, yeah, Mike, what's going on? Like, hey, do you think you could slow it down? And he's like, slow it down while we're crushing it over here. Well, we said 4 days, $400. Don't you think it'd be best if you get the full $400? He's like, yeah, I guess so. It's like, all right. So we need you to do is slow down, right? We have 2 walls remaining in this project. It's day number 1. All right, so 2 walls remain, and there's 3 days to paint still. So at what rate, what percent of a wall do I want this person to paint every day, so that we end the project at the end of day 4? There's 3 days left and 2 walls left. Obviously, it has to be less than 1 wall per day, right? What percentage of a wall do I want this person to paint every day in order to end on the very last moment on the 4th day? Not 50%, right? 50% of a wall is going to take an additional 4 days. We don't have 4 days. We have 3 days. There we go. 66% of a wall. So if we take these last 2 walls over here and we divide them into thirds, so it's got a top third, a middle third, and a bottom third, like this, for both of them, he'll come in on day 2 and he'll paint these top 2 thirds here for this one, and then on day 3 he'll come in and paint this bottom third and this top third, and then on day 4 he'll come in and he'll paint these last 2 thirds. Project over, right? That's the plan. So if we have him working at a 66% rate every day, and we continue to pay him $100 every day, this project will end at the end of day 4 having spent $400. That's TCPI. So in this case, our TCPI would be expressed as like this. TCPI would equal a 0.66. That's how we talk about TCPI. Now, if you want to discuss it as a percentage, just move the decimal 2 spots to the right. All right. So if your TCPI is less than 1, right, 1 represents 100%, that we want you to work at 100% rate of the plan. But in this case, we're ahead and we're trying to slow down. So we want you to do less than what we had planned. So less than 100%. So when your TCPI is less than a 1, a 0 point something, it's because you're ahead and you're trying to slow down in this situation. If our TCPI is more than 1, like a 1.5, that means you want the crew to work at 150% rate every day, every day, every day, every day. The work they would get done in 12 hours, you need them to get done in 8 hours. You know, now they're mad because we're trying to catch up. They're working over, you know, staying late, you know, working during lunch, all mad at you, right? Because you're trying to catch up. So when your TCPI is above a 1, it's because we're behind in the project, we're over budget, and we're trying to catch up with the remainder of the time we have remaining, you know, left in the project. Okay, so that's TCPI, the fixer. It's how we fix the project, get back on track at the very, very end. It doesn't fix it overnight. It fixes it over the remainder of the timeline. Okay, so that does it for all of earned value. That was all of it. And if you understood that conversation, then you're done. Hooray, right? The problem is when I flip the slide, all right, because it's the same conversation. It's just in formulas, all right? So formulas. All right, here we go. Look, if you don't like formulas, don't use them. Don't use them. Formulas are meant to help you and speed you up. But oftentimes we run into formula block. You know, people just hate it. They see the formula and just can't stop, you know, learning. Like, nope, turn off, and they want nothing to do with this. If you're one of those individuals, you know who you are. Don't use the formulas. They're not meant to trick you or make it harder. They're supposed to make it easier. So if they don't make it easier, don't use them. Replace them with sentences. Right? That's it. That's what you should do. As we're going through this and discussing the formula, write it out as a sentence so that you understand it. I would much rather you go into this exam memorizing 0 formulas, but understanding all of them, than just memorizing formulas and not understanding any of them. Because if you memorize a formula, that doesn't mean you're going to get the question right. If you understand a formula, you will. So I'd much rather you understand all the formulas. Memorizing them is a bonus too, right? But understanding them is what we're going for here. All right, so when it comes to the formulas on the slide, we see the basic 4 at the top of the slide: budget at completion, planned value, earned value, actual cost. There's not really a formula for those in the PMBOK guide, but we're saying, like, to determine the budget at completion, once you figure out the value of work, you just multiply it by the number of units, right? If there's 10 units and each one's worth $100, it's $100 times 10. That's the budget at completion, the value of all of the work. And then the planned value, once you figure out that unit of time, what each unit of time is worth, say every day is worth $100, all you have to do is figure out what day are we on. What day are you talking about? The 5th day, the 4th day, the 3rd day? Because once you figure that out, if you're talking about the 3rd day, every day is worth $100. So the planned value is 3 times $100. The PV3 is $300. All right. When it comes to earned value, to calculate that, we look at the work that is done and we multiply it by the value of work, right? So if we said every wall was worth $100 and we said we have 2 walls done, so it's just 2 times 100, $200. Actual cost, there's no formula for that. They will tell you the actual cost, right? Or you have to do the math backwards or something to solve for it some other way. But usually that's the number they give you, is actual cost, how much money was really spent. Okay, so then we have the 4 basic, so those are the 4 basic values. Then we see the 4 formulas here, which are used for project health. All right, so there's 2 systems here, right? There's cost and schedule variance and cost and schedule performance index. And they do the exact same thing, right? So cost variance and cost performance index do the same thing. They will tell you if the project's over budget or under budget. So why do we have 2 systems that do the same thing, variance and index? It's about audience, right? So variance will tell you a dollar amount. How far ahead a schedule or behind schedule, over budget, under budget we are is a dollar amount. So then I know like I'm $1,000 under budget, or I'm $500 ahead of schedule. That's what variance would tell me. So that's very useful within the project, within the team. But when I'm trying to compare projects to one another, and I go to Miguel, hey, Miguel, how's your project doing? And he's like, oh man, I'm all right. How's yours? Oh, dude, I'm crushing it. I'm $500 ahead of schedule. And Miguel's like, oh yeah, I'm crushing it more than you are. I'm $1,200 ahead of schedule. Is he actually doing better than me? We don't know. We can't, because it's relative to the budget, right? I'm running a popsicle stand over here, $400. His project's a trolley car in DC. It's like $10 billion. He's barely ahead, whereas I'm like crushing it. So as far as like how we're doing, comparing projects to one another, the dollar amount doesn't really help us, right? That's where index comes in. Index expresses it as a rate, and we can compare projects to one another with that rate, right? So if I said I'm 50% ahead of schedule, that's comparable to Miguel when he says I'm only 25% ahead of schedule, right? So that's what we're trying to do, is express how we're doing as a percentage so we can compare projects to one another using index. So that's why we have two different systems, one that we'll use to express how the project is doing within the team, and one that we'll use to compare projects to one another. All right, so now that we've talked the premise of them, let's go through each one. So let's first start with variance. We're talking project health and variance. All right, there's schedule health and cost health. To determine cost health, we're looking at the cost variance. The cost variance is the difference between how much we have completed versus how much we spent to do it, right? So we have completed, in our example, $200 worth of work, and we spent $100 to get it done. The difference between those, the variance, difference subtraction, would be $100. So we're just taking the earned value of 200 and subtracting how much we've actually spent, 100, and we get a positive $100. All right, so positive and negative is important here. If it's a positive number, that means that we are under budget. If it's a negative number, we are over budget. So the under over in variance is $0. $0 is perfect, no variance, on budget. Negative $1, over budget. Positive $1, under budget. Okay. Sorry. So our cost variance here is a positive $100. Schedule variance is a very similar concept. It's about how much work is done versus how much work was supposed to be done. So now the variables are earned value and planned value. We're going to compare how much work is done right now, $200, to what's supposed to be done, $100. So once again, I made the math simple for myself so I could do it and talk. So 200 minus 100 again is $100. So we have $100 of schedule variance, or we're $100 ahead of schedule. So it's a positive number, we say we're ahead of schedule. If it was a negative number, we would say behind. Okay, so that's the variance conversation. Let's do the same thing with index now. So with cost performance, to determine over budget, under budget, we use CPI. Now CPI, look at its variables. Earned value divided by actual cost. It's the same variables we saw for cost variance. The difference just division instead of subtraction. So we're going to take $200 and divide it by 100, giving us a 2, right? So we'd express it typically as 2.0. Usually take it out to 1 decimal point. So what this means, right, is the plan was to spend $1 and get $1 worth of work out of it. That's the plan, right? We're going to spend $100 and get one wall done, which is valued at $100, right? So for every dollar we're spending, we should get $1 in return for work. Unfortunately, that's not what actually happens. So in this case, we're spending $1 and we're getting $2 worth of work out of it. So for every dollar we spend, we're getting 200% return on that dollar. That's what CPI of a 2.0 means. That for every dollar we spend, we're getting 200% productivity out of that dollar. Okay. If our CPI was a 1, then we would be on budget. That's perfect. That means for every dollar we spend, we're getting $1 in work out of work, of work out of it. But imagine if your CPI was less than 1, like a 0.5. You're spending $1 and only getting 50 cents worth of work out of it. right? That means that you're going to miss your budget. You're going to be over budget because your rate of spending isn't matching the rate of work. You're spending more dollars to get less work done than you'd planned. All right, so CPI, the under over for the indexes is a 1. 1 is on budget or on schedule. But we have a 2.0, which means we are under budget. All right, so greater than 1, under budget. SPI is the same idea as schedule variance, but we're going to use division instead of subtraction again. So it's going to be 200 divided by 100, giving us a 2.0 again. And so the SPI of 2.0, what that means is that every day we're getting 100% of the planned work completed. If the plan was to complete X amount of work, every day we're completing X amount of work, that exact amount. If your SPI was a 1, right? So a 1 is perfect. 100% of the plan is being done. In our situation, our SPI is a 2, 2.0, which means every day we're getting 200% of the planned work completed. So every day we spend on the project, we're completing 200% of the plan. So our plan was to have 1 wall done. We have 2 walls done. All right. So that's SPI. All right. Now, after that, we have forecasting. We use that information to then forecast. We already discussed there's different ways in which that could happen. We'll see the different formulas for EAC on the next slide, but we're going to assume that, hey, he cheated on day 1, right? And he's not going to cheat ever again. So the whole project ends having spent $300, right? He's going to go back to 1 wall per day from here on out. So the project ends on day 3, $300, the project's over. When we're asked how many more dollars, we use estimate to completion, right? So the formula here is to plug in that forecast of $300 and then subtract how much we've actually spent, $100. So 300 minus 100 is $200. We're going to say, boss, spend $200 more dollars and this project will be over. All right. Now, our variance at completion is how far we're off from what we originally said. What we originally said is the budget at completion, $400. And now we're forecasting it to end at $300. The difference between that, different subtraction, is going to be $100. So we're saving you $100, boss. And when it's positive, suppose the project's doing well. It's negative, the project's doing poorly. All right, so TCPI we talked about as well is the rate to fix it, and we calculated this in our heads, and we said, oh, we need a CPI of 0.66 if we want to end this thing at the end of day 4 and spend all $400, right? Okay, so that's all of the math. Now let's take a look at the formulas explained for estimate at completion and TCPI. And so it's usually this slide where we see that quit in people's eyes. Like, no, look, you don't need these formulas. I already told you that. I want you to understand them, all right? Not just memorize them and try to regurgitate them. That doesn't help you. Understanding them does. So let's name these formulas. All right, so let's call this one option A, all right? So why is this formula called option A? The reason why I'm calling it option A is if you don't know, I want you to use option A. That's why we called it option A, all right? It's option A for a reason. You use it. If you don't know, use option A. When you don't know, use option A. That's why it's called option A. All right, so option A is the normal scenario. It's what's supposed to happen, right? Based off what happened yesterday, we're saying that should hold true tomorrow. And that's going to be more accurate than any old estimate, right? Because the dude told me it was going to be 1 wall per day, but he comes in and he paints 2 walls in a day, right? Obviously, his estimate was wrong. So we're going to use the data from yesterday to say when this project should end. So we did this in our heads. And, oh, look, at the end of day 1, he painted 2 walls. So that means at the end of day 2, he'll have all 4 walls painted and the project's over. So when we did this in our heads, we said $200 and the project's over. If he continues to paint 2 walls per day. All right, that's a way of solving this. Or we can use their fancy pants formula. So the formula for this, budget at completion divided by cumulative CPI, is correct. But on our exam, they only give you 1 CPI, all right, not multiple. You only look at 1 piece of work. So you can simplify the formula as budget at completion divided by CPI. So our budget at completion was $400, right? 400. We're going to divide that by our CPI. And our CPI was based off of the earned value and the actual cost, right? So earned value divided by actual cost equaled 2.0 for us. So that means our CPI is a 2.0. So we take $400 and we divide it by 2, we get $200, you soothsayers. They didn't need that formula. We can finger and toe math this. All right. So if you'd rather finger and toe math it, do that. All right. If you like the formula, use that. You don't have to use the formula if you don't want it. All right. As long as you understand what's going on here. Formula A, the normal situation, is to be used when our variances are expected to continue. As in what happened yesterday should be a good indication of what's going to happen tomorrow. Okay. But sometimes we can't use the data from yesterday because of some anomaly. Something has happened. It wouldn't make sense to continue using that. Like we figured out that, oh, he used child labor on day one. That's why we're ahead. He cheated. He broke the law. And he's never going to do that ever again. All right. So we can't use that data and apply that to the rest of the calendar. It doesn't make sense to do so. So in that situation, we use this formula. All right. We'll call it the anomaly formula, right? So the anomaly formula, we can call it option B if you want to call it option B. All right, option B, sure. So the anomaly formula, option B. My favorite name for it, zombie apocalypse, right? Because that's what it's like on test day. It's something weird. Right? They'll explain it to you, and you'll know. They'll tell you over and over again in that passage that the data from yesterday will have zero bearing on the remainder of the project. Right? It'll take them several sentences, if not paragraphs, to make that clear to you. They're going to say that what happened yesterday will never happen again, right? Or the variances we saw early in the project will never happen again and shouldn't be used in data moving forward, right? They'll say it in some way to make sure it's clear that you know that we can't use historical data, right? So in our situation, we said he used child labor. He's not going to do that ever again. So, okay. So if that's the case, he painted 2 walls on day 1. Right, that's one day done, and then so on day 2 he paints the 3rd wall, and on day 3 he paints the 4th wall. It's going to take us 3 days to paint all 4 walls, and we're paying $100 a day. So we figured out that our estimate completion would be $300. That's what we figured out with finger and toe math. $300, project over. All right, we could do that or use the fancy pants formula. So the formula for this is to take the total dollar amount of the project and then remove the anomaly. Right? So that's what's going on in the parentheses. They're taking the dollar amount of $400 for the entire project and then removing the anomaly from day 1, the $200 worth of work. So $400 minus $200 is $200. And then all we do is add in the actual cost, $100. So $200 plus $100 equals $300, you soothsayers. Right? So we can use the formula or we can common sense it, up to you. All right. So that's the anomaly formula. Once again, we know to use the anomaly formula because they're telling you that the data from the past will never happen again, ever, 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 right? And they're going to make it clear to you. It's going to be something really strange. It'll be obvious. In fact, you can almost look at the test question, and if it's like super, super long, you're like, oh, wow, this is an anomaly situation where what happened in the past will never happen again. All right, so that's formula A and formula B. And then we have the rebaselining formula. You don't need this on the exam, right? You're not going to rebaseline. And rebaselining is just addition. That's all it is. Look, addition. That's the math, right? So all you're doing when you rebaseline is hitting delete on all of your plans, then redoing them, adding them all together and how much you've spent so far, and then that's the new baseline. So if they're going to test you on that on this exam, they'd have to give you all of the remaining tasks in the project with new estimates and then ask you how much it should all cost. And you go, that's addition, right? And you're just adding them all together. They won't do that. It's too easy. So you're not going to see the rebaselining formula on this test. And then down below here, this formula, we call this one hyperdrive, right? Or the consulting formula, right? This one will always show you an exaggerated version of reality. And on test day, they don't want to know what is the absolute worst case or the best case. That's what this formula is designed to do. If the project's doing well, it'll tell you the best case scenario. If the project's doing poorly, it'll tell you the worst case scenario. That's what it's meant to do. It never tells you most likely. It's not meant to do that. It's meant to show you the extreme. So on our test questions, they want to know what's most likely to occur. That is option A or option B. Hyperdrive does not do that. So we can remove 2 of the 4 formulas for your exam. You won't use them. Common sense. All right, so now I've cut the EAC formulas in half for you. It's option A versus option B. Option A we use when it says your variances are expected to continue, and it will say that verbatim. Whereas option B, it's going to be something weird. A meteorite crashes into the building, catching it on fire. Your workers quit. You had to hire new workers. You don't expect to get hit by a meteorite ever again. Something like that, right? So the option B formula will be apparent. You'll know when to use it because of how long the passage is, and it's telling you that you can't use the historical data. Whereas option A, it just says your variances are expected to continue. All right, so that's our conversation for forecasting using EAC. It's option A or option B. Then we have TCPI, and it has two formulas as well. All right, so we can go ahead and remove this bottom formula. That won't be on your exam. The top formula will be. So this is the formula we use to figure out our TCPI. Now, we did it with finger and toe math, all right, to determine 0.66, or you can plug it in the formula, take our budget at completion, which is $400, subtract our earned value from it, that's $200, right? And then take our budget at completion, $400, and subtract our actual cost from it, right, which is $100, so that's $300. So $200 divided by $300 equals 0.66, right? So you can either do it that way or common sense it. Now, this one, typically, the formula helps to do it quickly. So anyway, the TCPI formula is pretty helpful when you have to, if you had to calculate it on the exam. It's just that they usually don't make you calculate it. They'll tell you that the TCPI is a 1.2. How's the project doing? And you're like, well, it must be doing badly because you're asking the crew to work at 120% rate every day. All right, so when it comes to TCPI, a 1 is on schedule, on budget. Anything below a 1 is saying, that we're ahead and we need to slow down. We want to work less than 100% every day. If it's above a 1, we're trying to speed up and do more than 100% of the work every day. So TCPI, essentially, from the perspective of the project manager, becomes your target CPI. I know it's called the 2 Completion Performance Index, but from the project manager's perspective, it's the target CPI. It's what we're trying to hit every day, moving forward. All right, so if you achieve that CPI from here on out, you'll end the project and hit the budget at completion. That's what it means.